integrate x cubed over the square root of 16 plus x squared. For this, we're going to use u substitution. Let's let u equal 16 plus x squared. The derivative of 16 is 0, and the derivative of x squared is 2x dx. Now, if we look at the integral, the denominator becomes the square root of u, which I'm just going to write it as u to the 1/2 power. On the top, you have x cubed dx. So notice that x cubed is the same thing as x times x squared. And we're going to grab the x from this equation. So if I divide both sides by 2, I get du over 2 is x dx. And then the x squared comes up from this one. So that means x squared is u minus 16. So we're going to multiply u minus 16 with du over 2 to end up with x cubed. And if we want to be precise, we also need a dx. So the top is just u minus 16 times du over 2, which the 1/2 I'm just going to put outside. And then we can split this up into two fractions. U over u to the 1/2 is just u to the 1/2. And then the u to the 1/2 will come up as u to negative 1/2. Now when we integrate, u to the 1/2 is u to the 3/2 times 2/3. And then this will be u to the 1/2 times, so 16 times 2 is 32. So it's minus 32 u to the 1/2. And then plus c. So we'll distribute the 1/2. 1/2 times 2/3 is 1/3. 1/2 times 32 is 16. Now we can replace u with 16 plus x squared. We could do some factoring. We can pull out a 16 plus x squared, square root of that. And then we have 1/3 times 16 plus x squared minus 16 plus c. And then from here, I'm just going to write like this, square root of 16 plus x squared. We have 1/3 times 16 minus 16. So we can multiply this by 3 over 3 and get 48 over 3. (16 over 3 minus 48 over 3), that's going to be negative 32 over 3. So I'm just going to write it like this. It's x squared minus 32 all over 3 plus c. And this is the final answer.